Welcome to Chapter 4. We're going to look at Section 4.3 today, Problem Solving in the Pharmacy. And this section is really going to build on Chapter 2, where we looked at some basic calculations of using the ratio proportion method that we went through, and then converting between units of measure in the metric system. And in this chapter, we're actually going to apply this, and we're going to look at problem solving with certain examples using actual problem sets and looking at prescription labels. So if we turn our books to page 88, the first one we're going to look at is example 4.3.1. A physician has ordered 370 milligrams of a drug, and you have a 10 ml vial on hand of a solution that contains 250 milligrams per 3 ml. How many milliliters will you measure out? So the first step we're going to do is we're going to identify the question being asked. What we need to find are how many milliliters. So X is going to be our unknown, and that is going to be in milliliters. And the second thing we're going to look at is the prescribed amount, and we're going to circle that. That's 370. So we know that the prescribed amount is going to go on the bottom of the first side of our proportion. We're going to identify the product available in the pharmacy, and we're going to underline it. In this example, the pharmacy has 250 milligrams in 3 mLs of the drug. We're also going to look at the extraneous information that's not important, and we're going to draw a line through it. In this case, it's the 10 ml vial. We're not concerned with that. So what we're also going to look at is the active ingredient to finish setting up our proportion. Whoops, that's a 3 ml over 250. Also important to keep in mind is that, again, we have our units of measure lining up in the denominator and also in the numerator. So from here, we're going to multiply to cancel this out, and we're going to multiply on this side as well. The milligrams will cancel out. We'll take 370 times 3, and then we will divide by 250. So X is going to equal 4.44, and our unit of measure is milliliters. So again, ratio proportion method, we're looking at the active ingredient that's desired, which is our unknown in this case, the vehicle that's desired, 370 milligrams, the active ingredient, and the vehicle on hand. You can also flip these. You can put X on the bottom and put the milligrams on the top if you choose to do it that way. That's completely fine. You just have to make sure that your units of measure also flip on the other side. So again, your milligrams have to line up and your milliliters have to line up. Let's take a look at some of the practice problems at the end of 4.3, and we'll go through a couple of the story problems together. So turn your books to page 91, and let's start with question number 1. A patient has a prescription order for 30 milligrams of a drug. The pharmacy has a partial container of 7.5 milligram tablets. How many tablets will the patient need? Okay, so what's our unknown? Our unknown are the tablets. That's our first step. So we know that X is going to be tabs. Our desired dose, 30 milligrams. So we know we're going to have milligrams over here, and we know we're going to have tabs over here. If there are 7.5 milligrams in each tab, whoops, it's kind of a messy one. That's a 1. Okay, so now we have our proportion set up. We're going to multiply to cancel this out on this side. Also multiply on this side. And our milligrams are going to cancel out. 30 times 1 is 30. We can isolate this if we want to rewrite it to make it a little bit easier to read. So 30 tabs divided by 7.5, and that is going to equal 4 tabs. All right, simple enough. The trick really is identifying, first of all, what we're solving for, and then identifying the desired dose and the on-hand available from the pharmacy, so we know that we're setting our proportion up properly. Number 2, a prescription order is written for 20 milligrams of medication. The pharmacy has on hand a 10 ml vial of 25 milligrams per 2 ml solution. How many milliliters will be prepared for this patient? So right there it asks you what the question is. How many milliliters? We know that that's what we're going to be looking for. So that's going to be our variable, our X. So that's our milliliters. We need to figure out what our desired dose is. Well, the prescription is written for 20 milligrams, so we know that that's the desired dose. We just need to find out how many milliliters of it we need. And what does it come in? It's available in a 2 milliliter per 25 milligram solution. And we know the milliliter is going to go on top because that matches up with what's on our other side. And the 10 ml vial is extraneous. We're not too worried about that. So to solve for X, we're going to put 20 and 20. That cancels out. We're going to do it over here as well. The milligrams are going to cancel out. 20 times 2 is 40. Remember, we're still looking at ml. 25 goes down. And again, I'm just rewriting it so it looks a little bit simpler. We're recognizing that the X has been isolated. So 40 divided by 25, and that comes out to X equals 1.6 milliliters. Always remembering to write our unit of measure at the end. Okay, let's do number 3. A prescription order is, whoops, wrong one. A patient is to get 125 milligrams of carbamazepine. The label at the right shows the drug that the pharmacy has in stock. So let's take a look. It says carbamazepine suspension, 100 milligrams per 5 ml. How many milliliters will be prepared for this patient? So we know that we, again, are looking for milliliters. That is going to be our variable. So X is going to reflect ml. What is our desired dose? Our desired dose is 125 milligrams. So we just need to find out how many mLs we need to get 125 milligrams in a dose. And the available stock that the pharmacy has is 5 ml per 100 milligrams. And again, making sure our units of measure line up, and they do. So we are going to isolate X by multiplying this out. That cancels out. So our X is by itself. We're going to do the same over here. The milligrams are going to cancel, so we're going to take 125 times 5, and then we're going to divide it, whoops, and then we're going to divide it by 100. And X is going to equal 6.25 ml. Okay. So we didn't have any extraneous information in this particular example. Let's look at number 5. A loading dose of 750 milligrams is needed. The pharmacy has on hand a 500 count bottle of 250 milligram capsules. How many capsules will be needed to fill this prescription? So we're trying to find how many caps. So that's going to be our variable. That's going to be X. X is going to be number of caps over our dose is 1750 milligrams. The available strength that the pharmacy has is 250 milligram caps. So one cap is going to equal 250 milligrams. And in this case, we do have some extraneous information. We're not concerned with how many are in the bottle. We just want to know what the strength is. So we're going to make sure our units of measure line up. They do. So let's isolate X, 1750 cancels out, times 1750. The milligrams are going to cancel out, so we're going to take 1750 divided by 250, and X is going to equal 7 capsules. All right, so that's easy enough. Most important part of the problem is first identifying what we are solving for. Okay, let's look at number 6. This has an example prescription label in it. A patient is to receive an 18 milligram dose of hydroxyzine pamoate. The pharmacy has the following medication available. How many milliliters will be prepared for this patient? Okay, so first let's look at what the pharmacy has available. And they have hydroxyzine pamoate, the brand name is Vistrol. They have that available as 25 milligrams per 5 ml. Okay, so let's figure out what we're solving for. How many milliliters will be prepared for this patient? So we are looking to find how many ml. So we know that that's going to be our variable. X is going to be ml. What is the desired dose? Well, the patient is supposed to receive an 18 milligram dose. So that's the desired dose. We just need to figure out how many mils they need. And the pharmacy has a 5 ml bottle, or 5 milliliters per dose, and 25 milligrams. Now it does say that the bottle is 1 pint, but that's going to be our extraneous information. We're not concerned with the size of the bottle. We just want to know what the strength is in each dose so we can figure out how many milliliters the patient needs. Okay, so making sure units of measure line up, they do. We'll go ahead and isolate X by multiplying. This cancels out. The milligrams are going to cancel out. We're going to take 18 times 5 and divide that by 25. And that is going to come to 3.6 ml. Okay, let's do one more together. Let's look at number 7. This also has a prescription label that we can look at. A patient is to receive 400 milligrams of erythromycin ethyl succinate 3 times a day. The available drug is shown in the label, and the available drug is 200 milligrams per 5 ml. How many milliliters will be prepared for the morning dose? Okay, so again, we are looking to find milliliters. That is going to be our variable. That will be X. And the patient's supposed to receive a dose of 400 milligrams. So that's our desired dose. That will go on the bottom. So we know that we're going to have mLs over here and milligrams down here. The available dosage from looking at the label is going to be 5 ml. And there are 200 milligrams in every 5 ml. So our units line up. We are ready to solve for X. 400 milligrams up here is going to cancel these two out. We're going to do the same to the other side. These milligrams are going to cancel out. We're going to take 400 times 5. So if we rewrite it down here, that gives us 2,000 ml. We're going to divide that by 200. So X is going to equal 10 ml. And that is for the morning dose. Now don't forget, they're taking it 3 times a day. So they're going to take 3 ml 3 times. So their total daily dose is 3 ml, but the morning dose, only 10. Okay, so hopefully that has helped you get a little bit more comfortable in solving and reading story problems. If you have any questions, go ahead and post those to the Q&A, and good luck working out the rest of the practice problems.